Students, welcome to Sunil's tutorial. I'm Sunil Mirwani and today we'll be doing this chapter called as time and distance. Let's see some guys, please start writing. A person can walk 300 meters in 30 minutes. Find his speed in kilometers per hour. You have to find his speed in kilometers per hour. Okay. Now guys, you're supposed to know the formula that speed is equal to distance upon time. Speed is equal to distance upon time. Right? Now distance is given to you as 300 meters. Time is given to you as 30 minutes. Right? But they have asked you the answer in kilometers per hour. So I want to convert from meters to kilometers. To convert from meters to kilometers, you divide by 1000. So this will be 300 upon 1000 kilometers. You have to convert time from minutes to hours. To convert from minutes to hours, you divide by 60. So that means this will be 0, 0 gone. This is 0.3. Ones are twos upon 0.5 kilometers per hour. Decimal will go 3 upon 5, that's 6 upon 10, 0.6 kilometers per hour. Right? So your answer is going to be 0.6 kilometers per hour. Next, let's see another sum, guys. A car runs 40 kilometers per hour. Car runs 40 kilometers per hour. A person travels half as fast as car. A person travels half as fast as the car. A person travels half as fast as the car. He covered a distance of D in 10 minutes. He covered a distance of D in 10 minutes. Right? Find D. Now, they are saying that a car travels at 40 kilometers per hour. A person travels half as fast as the car. So that means, what will be the speed of the person? The person travels half as fast as the car. Car is 40, so the person is going to be traveling at 20 kilometers per hour. Right? Now, they are saying that they give you how much is the time. We know that speed is equal to distance upon time. Right? They've asked you to find out the distance. So distance is going to be equal to speed into time. Speed is 20. Time is given to you as 10 minutes. Now since the speed is in kilometers per hour, you have to convert time in hours. I explained to you to convert from minutes to hours, you have to divide by 60. Right? So 0, 0 gone. So answer is going to be nothing but 10 upon 3 kilometers. That is 3.3 kilometers. So he covers a distance of 3.3 kilometers. Next, let's see another sum, guys. A boat takes 2 times as long to row a distance upstream. A boat takes 2 times as long to row. A boat takes 2 times as long to row a distance upstream or distance upstream as it takes to row the same distance downstream. As it takes to row the same distance downstream. If the river flows at a rate of 1 kilometer per hour, if river flows at 1 kilometer per hour, find the speed of the boat. Find speed of boat in still water. Right? Now they are saying that a boat takes 2 times as long to row a distance upstream as it takes to row downstream. Now let us assume that the speed of the boat in still water is x kilometers per hour. Let speed of boat in still water equal to x kilometers per hour. Right? Therefore, the downstream speed downstream will be how much? Still water is x and the stream flow of the stream is, they give you 1 kilometers per hour. So it will be x plus 1. Speed upstream is going to be x minus 1. Now, they are saying that a boat takes twice as long. Now let's see the speed, distance, time, upstream, downstream. We found out that the upstream speed is x minus 1, right? Distance, let us assume, is d. Downstream speed is x plus 1, distance is d. Now we know that time is going to be nothing but distance upon speed. So it is going to be d upon x minus 1 and this is going to be d upon x plus 1. But it takes twice as long to row a distance upstream, right? That means the upstream time is twice the downstream time. The upstream time is twice the downstream time. D and D gets cancelled, right? Cross multiply, so you will get this as x plus 1 is twice x minus 1, x plus 1 is 2x minus 2, so you will get 2 plus 1 is 2x minus x, 3 is equal to x. So the speed of the boat in still water is 3 kilometers per hour. Fine, do we get this thing here? Next, take down the next one please. A man goes 150 meters to the east. A man goes 150 meters east and then 200 meters north. How far is he from the starting point? Let's assume that the man is initially situated at point A. He goes east. This is his east. He goes 150 meters east. Then he goes 200 meters north. 200 meters north. How far is he from the starting point? How far is he from the starting point? I can find this by using Pythagoras theorem. Let's call this point as B. Let's call this point as C. If I use Pythagoras theorem, I can say AC square is AB square plus BC square. So AB square, that's 150 square plus 200 square. 15 15s are 225, 2 zeros, 2 2s are 4, 4 zeros. So this is going to be 0 0 5 2 625 25 0 AC square is 250 square, AC is 250. Is 250 meters away from the starting point. Next, let's see another sum, guys. The speed of the boat in still water is speed of boat in still water. Speed of boat in still water is 15 kilometers per hour. It goes 30 kilometers upstream, 30 kilometers upstream, and returns downstream to the original point, and returns downstream to the original point in 4 hours 30 minutes. Find the speed of the stream. Find speed of stream. Right? Now, they've asked you to find out the speed of the stream. Let us assume that the speed of the stream is x kilometers per hour. Right? Let speed of stream be x kilometers per hour. Right? In that case, I can say that speed upstream is going to be nothing but 15 minus x, and speed downstream is going to be 15 plus x. Right? Now, they're saying that it goes 30 kilometers upstream and downstream. Okay, let's see the speed, distance, time, upstream, downstream. Right, we found out that the upstream speed is 15 minus x, downstream speed is 15 plus x, distance is 30 kilometers. Right, now we know that time is nothing but distance upon speed. So 30 upon 15 minus x and 30 upon 15 plus x. Right? Now they are saying that the total time taken to go upstream and come back is 4 hours 30 minutes. Therefore, I can say that upstream time plus downstream time is 4 hours 30 minutes. Now, since the speed is in kilometers per hour, your time should also be in kilometers per hour. Here I could take 30 common. 1 upon 15 minus x plus 1 upon 15 plus x is 4 hours plus 30 minutes. To convert that into hours, you have to divide by 60. Right? So 30 common. This is going to be 15 plus x plus 15 minus x LCM. 15 plus x plus 15 minus x. In the denominator, it is going to be a minus b, a plus b. A minus b, a plus b is a square minus b square. So that's 15 square, which will be 225 minus x square is 4 hours plus 0.5 hours. Right? Plus x minus x gets cancelled. So you will get 30 into 30 upon 225 minus x square is 4.5. Take the 225 minus x square on the other side. So 30 into 30 upon 4.5 is 225 minus x square. 4.5 can be written as 45 upon 10. It's always advisable to get rid of the decimal as fast as possible because that makes things easier. So this will be 30 into 30. 4.5 can be written as 45 upon 10 is 225 minus x square. Right? Now, 5 2s are, 5 9s are, 3 1s are, 10s are, 3 1s are, 10s are. 100. 200 is equal to 225 minus x square. Take x square on this side, so 225 minus 200, x square is 25, x is 5 kilometers per hour. Speed of the stream is 5 kilometers per hour. Right? Next, let's move on to the next sum, guys. Sohan travels from A to B. Sohan travels from A to B at 12 kilometers per hour and returns at 18 kilometers per hour. Right? Mohan travels from A to B at 15 kilometers per hour. At 15 kilometers per hour, Mohan travels from A to B at 15 kilometers per hour. If he takes 30 minutes less than Sohan, if he takes 30 minutes less than Sohan, then what is the distance between A and B? What is distance between A and B? Right? Now, they've given you that Sohan travels from A to B at 12 kilometers per hour, right? Now let's assume that let distance between A and B equal to x kilometers, right? Let's assume x is the distance between A and B, right? Now, that means Sohan, the time that Mohan travels from A to B at 15 kilometers per hour, he takes 30 minutes less. That means Sohan's total time minus Mohan's total time should give you 30 minutes, right? Sohan's time we know is distance upon speed. Distance is x. His going time is 12 kilometers. His coming time is 18 kilometers per hour. This will be the total time taken by Sohan to go from A to B and come back. Guys, do we understand this? Right? Minus the time taken by Mohan. Mohan goes and comes at 15 kilometers per hour. So the total time taken by Mohan to go is x upon 15, to come back is also x upon 15. The difference between Sohan and Mohan's time is 30 minutes. Fine, do we get this thing here? So this is going to be 6 2s are 6 3s are. So in that case, this is going to be 3x plus 2x minus 2x upon 15. Convert this into hours because time is in hours. So this is 30 upon 60 hours. So this is going to be 5x upon 36 minus 2x upon 15 is going to be 1 upon 2. Right, guys, I've done LCM. Now, here this is going to be 3 12s are 36, 3 5s are 15. Right? That means this is going to be 25x minus 12, 24x is 1 by 2. If I do LCM here, right? So this is going to be x is equal to 3 into 12 into 5 upon 2, 6. This is 6 5 are 30, 33 are 90 kilometers. The distance between A and B is 90 kilometers. Fine, do we get this thing here? Next, let's move on to the next one, guys. A student reached his school late. A student reached his school late by 20 minutes by traveling at speed of 9 kilometers per hour. Right? Had he traveled at a speed of 12 kilometers per hour, and he traveled at a speed of 12 kilometers per hour, had he traveled at a speed of 12 kilometers per hour, he would have reached his school 20 minutes early. He would have reached his school 20 minutes early. Right? Find the distance between the house and the school. Find distance between house and school. Right? Now, here, let's see this. Speed, distance, time. Case 1. When he is traveling at 9 kilometers per hour, let's assume that the distance between the house and the school is x. Then the time taken by him, time is going to be nothing but distance upon speed. Right? Case 2, when he is traveling at 12 kilometers per hour, he would still be covering the same distance. The distance between house and school will not change, in which case time will be x by 12. In the first case, he reaches 20 minutes late. In the second case, he reaches 20 minutes early. So what is the difference between the time in the two cases? 40 minutes. Right? Here he is 20 minutes late, here he is 20 minutes early. That means the difference between the two time is 40 minutes. Right? Do you understand this? So in that case, x upon 9 minus x upon 12 should give you 40 minutes. Right? So this is 3 3s are 9, 3 4s are 12. So in that case, this is going to be 4x minus 3x. Convert this into hours, 40 upon 60. So in that case, I will get x is equal to 0 0 gone, 2s are 3s are 2 into 3 into 3 into 4 upon 3. 3 and 3 gone, x 4 3s are 12, 2s are 24. That's the distance between the school and the house. Next, let's see another sum, guys. In a kilometer race, A beats B by 100 meters. And B beats C by 150 meters. B beats C by 150 meters. Right? In the same race, by how much meter does A beat C? In the same race, by how much meters does A beat C? Right? Now, let's see this. Now, it's a kilometer race. Okay. Now, in a kilometer race, A beats B by 100 meters. That means by the time A covers 1000 meters, 1 kilometer is 1000 meters. In a kilometer race, A beats B. That means A has crossed the line. If A has crossed the line, that means he has covered 1000 meters. A beats B by 100 meters. So by the time A covers 1000 meters, B covers 900 meters. Right? Now B beats C by 150 meters. Right? By the time B covers 1000 meters, C covers 150 meters. Sorry, not 150 meters, sorry, 850 meters, because he beats him by 150 meters. Right? Do we get this thing here? So in that case, what is the comparison between A and C? I can say therefore C will cover I'll practice this way. A, B, C. If A covers 1000 meters, B covers 900 meters. If B covers 1000 meters, A covers 850 meters. Sorry, C covers 850 meters. Right? So first let's compare between B and C. I want to find out how much distance would have C covered by the time so I can say that here, if I compare this, let's assume that this is X. So X is going to be nothing but 900 into 850 by 1000. If I use unitary method, 900 into 850 by 1000, 0, 0, 1, 0, 0, 1, another 0, 1, 9 5s are 45, 9 8s are 72, 765 meters. So by the time A covers 1000 meters, B would have covered 765 meters. Therefore, A beats C by 1000 minus 765. 235 meters. So A beats C by 235 meters. Fine, do we get this thing here? Next, let's see another sum, guys. The distance between 2 points P and Q, distance between 2 points P and Q is 162 meters. A train starts from P to Q. A train starts from P to Q. A train starts from P to Q. At the same time, another train starts from Q to P. At the same time, another train starts from Q to P. Fine. They meet each other after 6 hours. They meet each other after 6 hours. Right? If train P travels at 8 kilometers per hour faster than the other one, find the speed of the two trains. If train from P travels 8 kilometers per hour faster than the other, find the speed of the two trains. Right? Now, you have 2 points P and Q. The distance between them is given to you as 162 kilometers. Right? Let us assume that train from P covers a distance of x kilometers when they meet. So in that case, the train from Q would have covered a distance of 162 minus x kilometers. If the first train is covering a distance of x kilometers, the other train would have covered a distance of 162 minus x kilometers. Right? Now, let's see this speed, distance, time. Right? Now, Now let's assume that the speed, this is from P and from Q. Let us assume that the speed of the train from P, if the train from P travels 8 kilometers faster, let's assume that this speed is say y. The speed of the train which has started from Q is y. In that case, the speed of the train which has started from P will be y plus 8, because they are saying that the train that starts from P travels 8 kilometers per hour faster, right? Distance. This is covering a distance of x. This is covering a distance of 162 minus x. Time we know is nothing but distance upon speed. So this is going to be x upon y plus 8. And this is going to be nothing but 162 minus x upon y. Right? So I now know the total time that they will take. Now, I can say that they are saying that the two trains meet after 6 hours, right? In that case, what is the effective speed of the two trains? The effective speed of the two trains is y plus 8. One train is traveling at a speed of y, the other is traveling at a speed of y plus 8. So the total speed is 2y plus 8. Right? Now, the total distance that they have to cover is 162 meters. Right? That means if this is the distance they have to cover and this is their speed, then they will meet after time is nothing but distance upon speed. Distance is 162 kilometers, speed is 2y plus 8, but they have said that they meet after 6 hours. That means this time 162 upon 2y plus 8 is 6 hours, right? Now simplify this equation, you should get your answer. 162 is 12y plus 6 8 are 48. 162 minus 48 is 12y. This is 8, 4, this becomes 5, so this is 1. So this is going to be 114 is 12y. Y is 114 upon 12, that will come up to 19 upon 2, 9.5 kilometers per hour. So speed of train Q is 9.5 kilometers per hour. If this is speed of train Q, then y plus 8 will be 9.5 plus 8, 17.5 kmph, kilometers per hour. Right? Do we get this in clear? Okay, we'll stop this here for the day. Thank you very much.